Hey guys, welcome back to the channel and Happy New Year to all of you. If you are a long-time subscriber to my channel, you may remember that a couple of years ago, I designed and built an open source ASCOM compatible flat panel. It worked great, but I eventually came up with an even better design. Could this be the best flat panel in the world? That's what we're going to talk about in this video, so let's get started. First, a quick reminder in case you are relatively new to astrophotography. Flat frames, or flats for short, are images of an evenly illuminated light source. They are absolutely essential during the calibration process to correct for vignetting or to remove shadows created by dust motes in your imaging train. So it is critical to take a good set of flats for each of your filters every time you make a change to your imaging train. There are many ways you can take flat frames. The cheapest solution by far is the famous white t-shirt method, in which you stretch a white t-shirt over the objective lens of your telescope and secure it with a rubber band. Then you point the telescope towards the sky in the early evening and take a series of images through each filter, modulating the exposure to try and reach a histogram peak between 1/3 and 1/2 of the maximum ADU range of your camera. While this method works, it is not always practical because it requires you to take flats early in the evening or wait until the next morning in order to have a sufficiently bright sky. To work around this limitation, you can use a flat panel. And if you are just getting started in astrophotography, my recommendation is to purchase an LED tracing panel for about $20 on Amazon. These can be dimmed manually, which is useful to deal with filters that have a wildly different bandpass, although the range of brightness is not so great. So you will still need to modulate the exposure time, and in some cases, especially with a luminance filter, if your exposure is sufficiently short, you might start seeing artifacts like bending, caused by the PWM signal used to power the LED strip inside the panel. To compensate for that, you would need to increase the exposure time by inserting sheets of paper in front of the panel to further dim the screen. So while these panels are an exceptionally affordable way of taking flats, and they can work very well, they can also be a bit of a headache, especially if you use a monochrome camera with a full set of LRGB and SHO filters. And that is where ASCOM compatible flat panels become really useful, because their brightness can be programmatically modulated, which simplifies everything. There are many commercially available ASCOM-compatible flat panels on the market, though they can be a bit expensive. There are also plenty of DIY solutions, including my own, which I talked about on this channel a couple of years ago, and I'll put a link to that video right here and in the description of this video. I like my DIY flat panel, and I successfully used it for 2 years with my Astrotech refractor. However, as you probably know, I recently acquired a new OTA, the ASCAR 151 PHQ, and I decided it was a good time to design and build a new version of this flat panel in which I would correct a few issues I've encountered with the first version. You will find this new version of my flat panel in a new GitHub repository. I'll put a link to it right here and in the description of this video. Let me explain some of the improvements I've implemented. The most annoying characteristic of my DIY flat panel project was that it required 2 cables, a 12-volt DC cable to provide power to the LED strip and a USB-C cable for the microcontroller to receive instructions from the computer. Some people who have built this project managed to get rid of the power cable by simply powering the LED strip using the 5-volt output that is available on most microcontroller boards. In practice, this works well, especially with small telescopes, because the LED strip does not need that much current, and the voltage regulator on most microcontroller boards can source up to 500 milliamps without getting too hot. While this was already a nice improvement, I decided to go one step further. In this second iteration of the project, I made the unit completely wireless. I believe that this is the first and only ASCOM-compatible wireless flat panel in the world. Let me show you how it works. The panel is powered by a 1 amp hour LiPo battery. Upon turning on the panel, the colored LEDs on the top will tell you how much charge you have left. Then, after a few seconds, only the red LED remains on. Here it flashes to indicate that the device is not currently connected to an ASCOM client application. In Nina, for example, I can configure the driver to connect to the specific device by pairing it using its Bluetooth address. This one-time operation guarantees that if there is another such unit in the area, I won't mistakenly connect to the wrong panel. Upon connecting to the device, the red LED stops blinking and turns solid red. At this point, the panel can be controlled by Nina or any other ASCOM client application. In Nina, the Flat Wizard will automatically control the camera, the filter wheel, and the flat panel, making acquiring flats for all 7 filters in my filter wheel a simple one-click operation. The frequency of the PWM signal used to control the brightness of the LED strip is roughly 4 kHz, which means that exposures as short as 0.1 second should not show any kind of artifact. When you're done, simply disconnect from the device in Nina, at which point the red LED starts blinking again. To charge the onboard battery, simply connect a USB micro-B cable with the unit turned on, and the battery will automatically start charging. You won't need to recharge the battery very often. A 1 amp hour battery will last a very long time, maybe 30 to 40 sessions, which is like a year of astrophotography for me. The second improvement to this flat panel, which was initially suggested by my friend Francesco Meschia, is that it now has 1024 levels of brightness, versus 256 for the first version. This small change from 8 bits to 10 bits allows you to keep the same 1 second exposure, for example, across all of your filters, from the luminance filter to a 3 nanometer narrowband filter and everything else in between, which can be convenient, especially if you use dark flats. Another small change I introduced, and this is more a bug fix than an enhancement, is that I now use a 3.3 volt logic level MOSFET to control the LED strip, whereas in the first version I was using a 5 volt logic level MOSFET, which could not be fully turned on by most small microcontroller boards like the Arduino Xiao or the Arduino Nano. Additionally, this time around, I designed the electronics in KiCad. This has allowed me to have a company like PCBWay manufacture the PCB for me. You still have to solder the components yourself, but it is a lot easier than using a perf board, and the result is more compact and looks a lot more professional. The ASCOM driver and the firmware were completely rewritten from scratch, and the driver can now be installed using an installer instead of requiring semi-obscure command line instructions that a lot of you seem to have struggled with in the past while using the first version of this project. I completely overhauled the 3D model, and this new version, which implements all the best practices in 3D modeling, will scale to any dimension without causing any error in FreeCAD. I also rewrote the documentation, which is in the README of the GitHub repository. In particular, I explain in much greater detail how to properly cut the light-getting plate, which is the secret sauce that makes the panel possible, as well as the diffusers. I added a lot of photographs to the README, so hopefully the instructions are much clearer now. This panel works very well. I have used it with Nina, and with the Flat Wizard in dynamic brightness mode, it is an absolute pleasure to use. Taking flats has become a very simple and straightforward one-click operation, and it yields reliable and repeatable results. All that for an estimated $75 US to manufacture, which I think is not bad at all. If you are interested in building this project, please read the FAQ section of the README first. Then determine whether this is a project you are willing to take on. I would not say that it is difficult to build, but it requires a bit of time and patience, and I would recommend building it with other people, maybe as part of a club project, for example. If you need an ASCOM compatible flat panel but don't want to build this project, Or if you want to have a motorized flat panel and cover for your telescope, I recommend you check out Deep Sky DAD. I don't have a business relationship with that company, but I don't mind supporting a small business that makes quality equipment available at an affordable price. If you get some value from my videos, please consider supporting this channel. There are many ways you can do that. You can click like and leave a comment. Also consider using the affiliate links I put in the description of this video if you would like to buy anything from Agena Astro. And if you feel extra generous, you can also send me a tip by clicking on the thanks button located right underneath this video, or click on the donate with PayPal button in the README of the GitHub repository. I really appreciate all of your support and encouragement. I'll be back in a few weeks, so until next time, thank you for watching.